No.
Good afternoon, dear teacher, dear student. I'm here to talk about gas injector for flotation columns. Well, first a little context. Flotation is a process where you have it's a process of concentration or separation depending on what you want. You have a particle that's either hydrophobic or hydrophilic. You have a phase as liquid and you inject gas. Flotation problems comes from the gas injectors that you can see here. That's the injectors that now use the flotation columns for bubble generation. Well, problems. What happens? The key process of flotation is the bubble generation. Why? If you had a big bubble, you have problems in something that is called attaching time. What is that? It's the time when a particle that is hydrophobic attached to this bubble. What happens if the bubble is too big? The bubble, as it's moved through the column, it has a film of water. This film of water is moving with the bubble, and the particle has to penetrate this film to get to the air, to get to the bubble where the air is. If the bubble is too big, it moves fast, making the attach time too short for great particles of solid to attach. If the bubble is too small, the particle doesn't have the area in the bubble to attach. It touches the bubble, but it slides and it falls. So we have the problem that if we generate too much big bubbles or too much small bubbles, we will have problem in recovery of the mineral that we are flotating. So we have to manage to achieve optimum diameter of bubble. How? We need to measure the diameter of bubble. How we do this with a technology called image analysis. We take pictures of bubbles, then we process them in a software called MATLAB that has annex with image analysis. This image analysis measures the diameter of bubble and make a distribution. That means that I have how many bubbles do I have with this diameter and with other diameter. Then we design a new injector. As you see in the previous image, the injector was just this part, but the people generate this new concept, adding a new surface where the gas contact with the surface and then generate bubbles. The results. Well, as you can see in this graphic, we measure the bubble diameter, making the distribution increasing the optimal bubble diameter. I mean, we generate more bubbles that have the optimum diameter, making the big bubble less and the small bubble equally less. What we gain with this? We gain that we can make, I will call it better bubbles, because they have the diameter that we need. That will give us the exact time of attach to recover any kind of mineral that we are floating. Thank you very much, and that's all.